Have you ever looked out your window to see precipitation that isn't quite snow, nor is it strictly rain, but something in between that bounces off surfaces with a distinctive tap? This fascinating phenomenon is a common occurrence in certain weather conditions, and it tells a compelling story about our atmosphere's layered structure. Raindrops transform into ice pellets, often called sleet, when they fall through a specific temperature profile in the atmosphere. Essentially, rain forms in a warm layer aloft, then falls into a freezing layer of air near the Earth's surface that is deep enough to allow the raindrops to completely freeze into small, translucent ice spheres before they hit the ground. The key mechanism for this transformation is the vertical temperature structure of the lower atmosphere. For sleet to occur, there must be a layer of air at or above freezing temperatures, typically above about 4,000 feet, where precipitation initially forms as rain or melts into rain. Below this warm layer, there must be a subsequent, deeper layer of subfreezing air, typically at or below the freezing point of 0 degrees Celsius or 32 degrees Fahrenheit, extending down to the surface. As the liquid raindrops descend through this sufficiently cold layer, they supercool and then freeze solid, creating those characteristic ice pellets. To observe this process in action, you can pay close attention to local weather reports, specifically looking for atmospheric soundings or temperature profiles. These reports often show temperature inversions, which are essential for sleet formation. A telltale sign of ice pellets is their distinctive sound as they strike objects, creating a rattling noise unlike the soft landing of snow or the splattering of rain. Understanding the nuanced differences between types of winter precipitation, such as sleet versus freezing rain, reveals the subtle yet critical variations in atmospheric conditions. Freezing rain, for instance, occurs when the subfreezing layer near the ground is too shallow to allow the raindrops to fully freeze before impact, causing them to freeze upon contact with surfaces. The depth of that crucial cold air layer determines whether you see sleet or a coating of ice. So, the next time you encounter ice pellets, you will understand that you are witnessing a precise atmospheric dance, where temperature layers dictate the vary from precipitation takes. It is a clear demonstration of how specific vertical temperature gradients within the hydrological cycle lead to unique and observable weather events, turning simple raindrops into tiny, bouncing spheres of ice.
If you love learning about water, like, subscribe, and keep exploring with us.